Welcome to another set of video notes. Today we're moving on to 2.5 and we're going to do how to model direct variation. Now after everything we've been through, slope and y-intercept and point slope formula, this is actually one of the easiest lessons that you're going to get this year. So enjoy. The formula for direct variation is y equals ax. Sometimes we say y varies directly with x, and we refer to a as the constant of variation. Now if you think about slope-intercept form, how is this different from slope-intercept form? Well, hopefully right now you're saying, oh, well wait, there's no b. And that's because the b is actually 0, okay? A is known as the constant of variation, but it's really just the slope of the line, okay? When you look at a graph of direct variation, whether it comes down, oops, that wasn't very good. Whether it comes down like this, or whether it's a positive slope, it's always going to have to cross at the origin. So you might remind yourself, crosses at origin. It always has to hit there. If it doesn't, it's not direct variation. Okay, so I'm going to ask you to write and graph direct variation that has -4, 8 as a point. Well, what could the -4 take the place of? Hopefully you know it's a point, so it's the x-coordinate. And what does 8 take the place of? Yes, y. So now we go to our normal equation, y equals a times x. We're going to plug in 8 for the y. We don't know what a is, and we're going to plug in -4. Now, easy algebra, divide each side by -4. And you get a equals -2. So your slope, or your constant of variation, is -2. Now hopefully, all of you are really good at graphing this. And we're going to just make a little graph off to the side, do a couple lines here. Where's the y-intercept? Oh yeah, it always crosses at 0. And then if the slope is -2, what does that tell you? Well, remember, slope is rise over run. So you go down 2 and over 1. And here's your line, okay? And that's all there is to it. Here's the equation of the line. Here's the graph. We're going to do another one. Write and graph direct variation that has 5, 3 on the point. Once again, what can we plug the 5 in for? X. And the 3, yep, for y. So now go back to the formula, y equals ax. What did we say we were plugging in for y? Oh yeah, we labeled it. That helps, 3. We don't know a. We're solving for x. What was x? Oh yeah, 5. Do you know how to solve this? Oh good heavens, I hope so. And you get a equals 3/5. So our equation is just y equals 3/5 x. Okay, well, now we got to graph it. What's our y-intercept? That's where we start. Oh yeah, it's just this point at the middle, the origin, or the 0 that we don't write. Now, if your slope is 3/5, do you know how to find the next point? I hope you're all thinking in your mind that you are going to go up 3 units and over 5. And if you notice, this time it's rising. Oh yeah, because it's a positive slope. And since it's a number less than 1, it's a little flatter. It's not so steep. Okay? Does that seem pretty easy? Because it doesn't get much harder than this. So we've got a couple more examples that we want to do. For your exercises, when you come back to class, one of the things I'm going to do is I'm going to give you a couple different equations, and I'm going to say, is this direct variation? And if it is, I'll want to know what the constant. Well, let's look at this. Well, we got to get y by itself, right? Add 4. And here's a good question. Can you combine 3x and 4? No, they're not like terms, okay? Does this form look like our beginning one? No, because it doesn't cross at 0. So we'd say no, and you're done. Your other example that I have is right up here. Now, this kind of looks similar, but I think y was by itself. So what would we do to get y by itself? Well, we're multiplying, so to undo it, you divide, and now you get y equals 1/6 x. Does that look like it? Yep. So then you tell me that the constant of variation, and I kind of cheated, I didn't write out the whole thing up here, but you probably should write out, at least write var for variation, is 1/6. Okay? Is that very difficult? No? Good. Isn't it great how I can hear what you're saying right now while you watch these notes? Okay, here's another type of problem. X and y varies directly. Write the equation, and then I'm going to ask you to find the x value when y equals -4. Well, you know the original equation is y equals ax. You've got an x, you've got a y. Any idea what we could do? Oh, I hope you're saying plug it in. So we put 8 in here. We don't know a, but we know x is -6. What do you do to get a by itself? Oh yeah, divide by -6, and you get a equals -4/3. So, the next thing that we want to do is write the equation. Leave the y, put in the a, and then you've got your x. Okay? Now, the last part asks us to find x when y is -4. So, what do we know y is -4, plug that in. Now, I picked this problem because I think this might be the worst part about it, because you might get a lot of fractions. Hopefully, most of you are saying, yes, x, to get it by itself, I need to get rid of this. So I need to divide by -4/3, but yeah. How about we do that reciprocal trick? Remember that? So multiply by -3/4. And put this over 1. Let's see, all this, the 4's cancel, the 2 negatives make positive. Yep, we're good, we're down to x. And let's see, -3 times -4, positive 12. All over 4 times 1 is 4, or in other words, divide it. Now remember, you can do that simplifying thing too. Those both have 4's in them, so you can get rid of them. -3 times -1 is 3. 1 times 1, oh yeah, either way you get 3. So you gave me the constant of variation, you wrote out the equation, and then you plugged it back in. Okay, almost done. Can you believe that? All right, the last type of problem you're really going to have to do, excuse me, is tell whether data is direct variation or not. I bet you just all said bless me, didn't you? Didn't you do that? I hope so. So, how do you tell if it's direct variation? Well, it should always fit into the same equation. Your A should be about the same. So think back to that 1.4 lesson where you had to get different things all by themselves. If I wanted to get the A by itself, how would I get rid of the X? Oh yeah, divide. So y over x, yeah. So that's what you're going to do. You're just going to always divide y by x. So -1 over 3, -2 over 6, -3 over 9, -4 over 12, -5 over 15. Do you notice anything about these? Oh, they can all be reduced to -1/3. So if they all reduce to -1/3, if they're all about the same, then you say, yes, the data is direct variation. Let's look here. If we take, once again, y divided by x, you might want to put that down on your study card to check if it's direct variation or not. Divide y by x. So 4 divided by 2, 9 divided by 3, 16 divided by 4, 25 divided by 5, 36 divided by 6. Well, let's see, what do we get? Here we get 2, 3, wow, these are changing, 4, 5. Are any of them even the same? No. So we are going to say no. It does not vary directly. So you can't write an equation. You're done with the problem. Okay? That's all I have for today, and I will see you in class. Bye.